Welcome to Chemistry with Caroline. In this video, we're going to take a look at anti-aromatic and non-aromatic compounds and how to characterize them. So we'll start with anti-aromatic compounds. An anti-aromatic compound has to be cyclic, so no linear systems would be categorized as anti-aromatic. It's got to be conjugated, which means it has to have p orbitals throughout the entire cyclic system. It has to be planar, and it has to have 4n electrons. So this is the formula that we use to calculate the number of electrons in an anti-aromatic system. So 4n is the formula. N could equal 1 or 2 or 3, etc. It's just a whole number. So just like aromatic compounds follow the formula 4n plus 2, anti-aromatic compounds follow the formula 4n. So when n equals 1, that would be a compound with 4 electrons. When n equals 2, that would be a compound with 8 electrons. And you can see a pattern emerges here. So every 4 electrons, we get a new number of electrons that would make a compound anti-aromatic. So cyclic conjugated planar compounds with 4, 8, 12, 16, and so on electrons would be categorized as anti-aromatic compounds. So let's go to the next slide and we'll look at an example. So in this example, I have cyclobutadiene. So I'm going to redraw this structure with the p orbitals on it. So it has pi bonds, right? 2 pi bonds in it. And the way I have it drawn, the pi bonds sort of look like they're here. There's 1. And then here. But you can see that every atom on this molecule has a p orbital on it. So it is conjugated throughout. It's cyclic. And if we assume that it's planar, then we can check our number of electrons to see the characteristics of this molecule. So if we look at the molecule, we have 2 pi bonds in this molecule. So there's 2 double bonds, right? Each double bond consists of a sigma plus a pi bond. And each bond, whether it be sigma or pi, has 2 electrons in it. So if I have 2 pi bonds, then I have a total of 4 electrons. So I want to know if 4n can equal 4, and of course it can if n equals 1. So if this molecule is planar, we already know it's cyclic and conjugated throughout. It's going to be an anti-aromatic compound because the number of electrons fit into that 4n formula. So here's another example. I have a cyclic conjugated system here. Every atom in this molecule has an unhybridized p orbital. In this case, again, all pi bonds. And so I have 1, 2, 3, 4 total pi bonds. So that gives me 8 electrons in that cyclic conjugated system. If it adopts a planar conformation, it would be an anti-aromatic compound because 4 times 2 equals 8. So I can make 4n equal the number of electrons. So what happened here is scientists observed that there was a class of conjugated organic molecules that exhibited extreme reactivity and were really unstable. And these molecules had 4n electrons, so they noticed a pattern. Now we can use that pattern to predict whether a molecule is anti-aromatic, even if we haven't seen that particular molecule before, okay? Because we can count the number of pi electrons in a cyclic conjugated system. So anti-aromatic compounds are found to be relatively unstable and short-lived. So let's go to the next slide and we'll look at the last category, which is what is a non-aromatic compound. So a non-aromatic compound is cyclic, but the difference is that it's not conjugated throughout. So there's some atom in there that is breaking up the conjugation of the pi system, and that happens by having an sp3 hybridized atom present. There's not an unhybridized p orbital in there. If you were doing resonance, you'd get stuck at that carbon atom. So we don't even have to count electrons when it comes to non-aromatic compounds. We just have to recognize that carbon that is disrupting the conjugation of the system. So this molecule would be described as a non-aromatic molecule. And any molecule that has a pi system broken up by an sp3 hybridized carbon, or it could be another atom too, anything that doesn't have a p orbital is going to be non-aromatic. So in terms of relative stability, Aromatic compounds are the most stable compounds, and those follow the 4n+2 rule. I have a separate video about that, so if you haven't checked that out, you should go watch that one. The middle stability would be non-aromatic compounds, and then the lowest stability would be anti-aromatic compounds, and those follow the 4n rule. So the number of electrons in the pi system for aromatic and anti-aromatic alternates. So you could have 2 electrons, 6 electrons, 10 electrons, 14 electrons, and so on. Whereas for 4n, you'd have 4 electrons, 8 electrons, 12 electrons, 16 electrons, and so on. So you can see they're alternating. To be either aromatic or anti-aromatic, the system has to be conjugated throughout, as well as cyclic and planar. While non-aromatic compounds have some atom in the cyclic system that's breaking up the conjugation of the system. So this has been a look at how to categorize anti-aromatic and non-aromatic compounds. If you found this video helpful, please like, subscribe, and share with your friends.